Hi, welcome to this new episode, and in this episode I am discussing the variation in conductivity with dilution, specifically for specific conductance kappa, molar conductivity or equivalent conductivity. So to understand the details, let's meet on the other side of the video. Welcome back. So here I would be discussing variance in conductance of an electrolytic solution. But before diving into details of variance in conductance, let's try to understand the types of conductions that are possible in electrolytic solution. So the types of conduction are there are two types of conductions. First would be specific conduction, and second would be molar or equivalent conduction. Now let's try to understand the definition of specific conductance. The specific conduction is the conductance observed in 1 centimeter cube of electrolytic solution. So now what does this mean? Say, for example, say this is an electrolytic solution, and this electrolytic solution is, say, of a strong electrolyte, or it can be of weak electrolyte. Now, if I am observing the specific conductance for this solution, then say this is, say, 1 centimeter cube of the solution. Say this is 1 centimeter cube of the solution. So the conductance or the ions or the charged particles that are present in this 1 centimeter cube of solution would be characterized as the specific conduction for this solution. So it is an important thing to remember that it is 1 centimeter cube of electrolytic solution would always characterize the specific conduction of that solution. So now coming on to equivalent or molar conduction, the definition would be it is the conduction observed in V milliliters of solution. So it is the total volume of the solution that would contribute to its molar conductance or equivalent conductance. Say, for example, there is a solution. There is a solution and the volume of the solution is, say, 200 ml or say 150 ml. And if I have placed an conductivity cell into it, so this total volume, the total number of ions present in this total volume, this would contribute to the total conductivity or the total ions that are present in this solution would contribute to the molar or equivalent conductivity of this solution. So this is the basic difference between molar conductivity and specific conductivity. It is in total solution, the volume of total solution is considered while considering the molar conductivity or equivalent conductivity. But in case of specific conductivity, we would be specifying only the 1 centimeter cube volume of the total solution. So it is the ions that are present in 1 centimeter cube of the solution, and molar or equivalent conductivity would be the total number of ions present in this V milliliters of solution. The definitions of specific conductivity, molar conductivity and equivalent conductivity are displayed on your screen. You can take a snapshot or you can jot it down. If you are jotting down, then just pause the video. So let's try to understand the variance in conduction of an electrolytic solution. Now, if you are not aware of what is electrolytic solution and how the conduction in electrolytic solution occurs, you can check the description box, and in the description box there is a link to the video about electrolytic conduction. So I'm presuming that you know electrolytic conduction and the principles of electrolytic conduction. So now the variance in conduction of an electrolytic solution is explained by Debye Huckel Onsager equation. So this equation shows a relationship between the molar conductivity and conductivity at infinitely diluted state, and they are related as molar conductivity is equal to conductivity at infinitely diluted state minus A under root C, where lambda m is molar conductivity lambda infinity would be conductivity at infinitely diluted state, and A would be minus A would be slope of the line, and C is concentration. So these are the basic terms in the equation. Now let's try to understand what is conductivity at infinitely diluted state. Now the conductivity at infinitely diluted state means the dilution of the solution is carried to such an extent that the concentration nearly becomes zero. Now it can't be possible that you can create a concentration zero in an electrolytic solution. So concentration is nearly negligible, or it is a state at which the concentration does not basically take part in the conduction of an electrolyte. So that state would be termed as infinitely diluted state. So this is all about the infinitely diluted state. So now you can take a snapshot of the screen or jot it down, the important terms in Debye Huckel Onsager equation. Now, as I have already stated that there are two types of electrolytes. To know more on types of electrolytes, there is a link in the description box. Now, in case of specific conduction, the variance in conductivity would basically, the conductivity of the solution would decrease. So when dilution is carried out, the specific conductivity or kappa basically decreases. Now let's try to understand what is the concept associated with it. Now, as I have already explained you that specific conductivity would be conductivity of the charge or carrier ions in 1 centimeter cube of the electrolytic solution. So say this is an electrolytic solution and this is the conductivity, that is specific conductivity, that is 1 centimeter cube of an electrolytic solution. Now let's say the conductance of this solution or the kappa for this solution is X. Now if I am diluting this solution, that is I am adding more water into it. So now I have added more water into it, and because of addition of water, now what would happen? Basically now number of ions that were present in this 1 centimeter cube would now decrease, because I have diluted this solution and number of ions now present in this 1 centimeter cube would decrease. So number of ions present per centimeter cube decreases. Therefore, current charge carrying capacity also decreases, because charge carrying capacity of the 1 centimeter cube solution decreases, so the specific conductivity decreases. So you can take a snapshot of your screen, or you can just jot it down, the important point that I have discussed for the decrease in conductivity, that is kappa, with dilution. Now let's try to understand the variance in conductivity of a solution, specifically in terms of molar or equivalent conductivity. So molar conductivity molar and equivalent conductivity are more or less same, only the difference is that here we are using molarity as a concentration, and in this we would be using normality as a concentration. So in these cases the conductivity of the solution would increase on dilution. So let's try to understand the variance in conductivity, either molar or equivalent conductivity on dilution, and how it increases with dilution. So if I consider a solution and say this is the volume of the solution, now in this volume there are few ions, say there are X number of ions in solution. Now when dilution is increased, so we are now in the same thing is happening. I am adding water into this, and after addition of water, the volume of the solution is increasing. Now, but one thing remains constant. In total solution, the number of ions has not changed, isn't it? If there were X number of ions in the solution in totality, now if I have increased the volume, the number of ions would remain same, because number of ions remain same, and in a process what has happened, the distance between ions has increased. Because distance between ion has increased, so mobility of ions increases, therefore conductivity increases. On your screen you have the details of equivalent and molar conductivity and how it increases. You can take a snapshot or you can jot it down. So this was all about the specific molar and equivalent conductivity variation with dilution. If you want to stay connected with us, then you can follow us on Facebook, Instagram and Twitter. If you haven't subscribed to our channel, then please do subscribe to the channel and don't forget to hit the bell icon to get instant notifications. As a student, it's an urge to attain good marks, good college, and to do so, one has to practice a lot. So you might be searching some questions, assignments, practice tests. So there's a link on the left top corner of the screen here above. So you can follow the link and get yourself registered and satisfy your urge. Thanks for watching the video.